entry of the opposite diagonal. So the opposite diagonal goes to sign minus. Otherwise, for bigger matrices, we use Laplace rule, which is called also expansion by cofactors. Let's see what are cofactors. Cofactors are determinants of submatrices. Sometimes we intend cofactors as submatrices. They are determinant of submatrices obtained by deleting each time one row and one column. So in the case 3 by 3, I need determinants of matrices of 2 by 2 to compute the determinant. So in general, a cofactor is what? A cofactor is, more precisely, its cofactor corresponds to what? Its cofactor corresponds to an entry. The cofactor of this entry is -1 to the sum of what? Of the indexes defining this cofactor times the determinants of what? Times the determinant of the submatrix obtained by deleting row I and column J. So if we have a matrix A, C11 is a determinant of -1 to the 1 plus 1, which is 2, times the determinant of the submatrix A11 obtained by A. So in this way, in order to determine the determinant of a matrix n by n, I need to know how to compute the determinant of a matrix n minus 1 times n minus 1. So in order to know how to compute the cofactors of a n by n matrix, I need to know how to compute determinants of n minus 1 times n minus 1 matrices. It's why I started giving this definition. Let me compute for a 2 by 2. Let me compute the matrix of the cofactors for a 2 by 2 matrix. Let me see IJA. So we start by A equal A11, A22, A12, A21. So the matrix of the cofactor Cij, so C of A. So in order to attain the entry 1, 1, I have to delete the first row and the first column, isn't it? And multiply by -1 to the second. So I have A2, 2. And here I have to delete first row, first column. I have to delete here first. Look the formula. I have to delete. Where is my? Sorry, I just realized that I actually inverted. Here it's A, the indexes. So be careful when you write the coefficients. So here I have minus A1, 2. And A1, 2. Here I have A1, 1. And here I have minus A2, 1. If you check the determinant of A in this case, or is equal to the determinant of the matrix of the cofactors. It's not in general true. It's why we need to define for the determinant for n equal 1 and then equal 2. So the Laplace rule is a formula, provides a formula to determine the determinant of its matrix depending on its cofactor. In which way? Developing the determinant either through a row, by a row, or a column. So you choose a row, say row I, and the determinant is AI1 times the cofactor corresponding to the entry I1 of the matrix plus AI2 times the cofactor corresponding to the entry I2 of the matrix plus AIN times the cofactor. You are expanding this determinant according to row